So here we are. We're going to actually do our first matrix multiplication. Unfortunately, it's not as easy as adding and subtracting them, but it's still not too difficult. All right, first thing I want to point out, and I'll show you what I mean by this here in a little bit. Matrix multiplication, the order does matter. So matrix A times matrix B is usually not the same as matrix B times matrix A. There's usually a difference. So it's not like your regular multiplication, 4 times 5 is equal to 5 times 4. It doesn't have that commutative property. All right, and then this the other thing here, I'll talk more about this later, but the dimensions, I don't know why I keep forgetting the S. The dimensions must line up. All right, so let's go ahead and do one of these. All right, so A and B, notice that they are both 2 by 2 matrices, and they're square matrices. Just means like the rows and columns are the same number. And we are going to find A times B. All right, so the the way it works is you're going to take the rows of your first matrix, and you're going to multiply it by the columns of your second matrix. So this is going to be that dot product stuff. So we're going to do this this first row and first column. All right. So we're going to multiply the corresponding pieces and add them together. So since we're doing first row and first column, this is going to be our first row, first column entry in our answer matrix. So I'm going to do 3 times 1, that's 3. 1 times 2, that's 2. And so I add them up. All right, let's do first column, first row and second column this time. So we're doing this row and the second column. So row 1, column 2. So it's going to be here. Row 1 and column 2. All right, 3 times 2 is going to be 6 plus 1 times 1. There you go. All right, I kind of divide these a little better. And then next we'll do this second row times the first column. So this is going to give us row 2, column 1. All right, so this position right here. Second row, first column. Negative 2 times 1 is negative 2 plus, it's always addition here, negative 4 times 2. So negative 8. All right, negative 2 plus 8 is what that says. And then the last one, we'll do negative 2 times 2 is negative 4 plus negative 4 times 1, negative 4. All right, so we were doing the rows. So the rows of this one had to match up with the columns of this one. We'll simplify this, and this will be our answer. 5, negative 10, 7, and negative 8. All right, I know that was exciting. Let's do the other way around. We're gonna use our same matrices, but instead we're gonna find B times A. All right, so B times A here. Let's do row 1 and this column. All right, so row 1, column 1. All right, so 1 times 3 is equal to 3, and 2 times negative 2 is equal to negative 4. All right. Oh boy, that's not going to be large enough. There we go. I'll write our answer down below or something. All right, and now let's do row 1, column 2. So it's going to give us this one up here. So it's going to be 1 times 1, which is 1, and then 2 times negative 4, which is negative 8, also plus negative 8. All right, now let's do the second row, first column. Second row, first column is going to give us this one. 2 times 3 is 6, plus 1 times negative 2. It's negative 2. And then we'll do second row, second column. 2 times 1 is the 2 plus 1 times -4. Boy, this is crazy. Haven't done this in a while. Let's see. 3 plus -4 is -1. 1 plus -8 is -7. And then 6 plus -2 is 4. And this one's -2. So you'll notice, if I set them side by side here, I guess you'll notice. There we go. You'll notice our answers for each of these are completely different. All right. This one was A times B. This one's B times A. So the moral of the story is order matters. Okay. Now, let's go ahead and we were already talking about how the rows had to line up with the columns. So the way this works is that your dimensions, they have to line up. What has to happen is these two numbers, all right, the columns of your first matrix and the rows of your second matrix, these inside numbers here, they have to line up. They have to be the same. Now, the answer to the multiplication is going to be these outside numbers. So we ended up with a 2 by 2 matrix over here. So let's here, let me go ahead and look at the dimensions here. This has got one row and it's got 3 columns. The second one here has 3 columns and 1 row. So the inside numbers, since those match, that means that this is doable. We are able to multiply them. The answer is going to be a 1 by 1 matrix, and you'll see why when we go to do it. All right, we'll distribute this scalar inside. So 3 times 4, this is going to be I'm just going to write my answers up here. 3 times 4 is a 12. 3 times 1 is 3, and then 18. So 12, 3, 18. Now, to multiply these two, remember it goes rows to columns, but there's only going to be one entry for this. It's a 1 by 1 matrix. So we're going to do this row times this column. All right. So 12 times 1, that's 12, plus 3 times 2, that's 6, and then 18 times 4, ooh, 72, I believe. Yeah, I bet it's 72. All right, and then whatever this adds up to, let's see here, 18 plus that, 90. All right, this is our matrix. That is our 1 by 1 answer matrix. All right, let's look at this one right here. All right, so this matrix it has 3 rows. So it's a 3 by 1 matrix. And then the second one is a 1 by 2 matrix. I mean, just looking at them, it doesn't look like you could put these two together anyway. But it says here that's going to work out, and our answer is going to be a 3 by 2 matrix. So those line up. This is what kind of answer we're going to get. A happy answer. Look at that. All right. All right, so we're going to do, we're going to do the rows of this matrix times the columns of this matrix. All right, so it's going to be row 1, column 1, which is just 15. All right, I'm going to go ahead and write it. This is a 3 by 2 that we're going to wind up with. So I'm going to go ahead and draw my 3 by 2 here. So my first answer is 15. My next one is going to be row 1, column 2. That's 30. Row 2, column 1. That's 3. The next one's going to be 6. Row 3, column 1 is a 6. And row 3, column 2. There you go. That's our answer. And it is a 3 by 2 matrix.